Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over how to factor special cases, namely difference of squares and perfect square trinomials. Don't forget to visit our website at mathgoodserve.com for access to a wide variety of tutorials ranging from algebra all the way to calculus. All right, so for the example we're going to go over, the task is to factor the following expression completely. So to factor the expression t to the fourth power minus 16 x squared minus 2t to the 4 minus 16 xy plus t to the fourth minus 16 y squared. Okay, so before we go ahead and factor this expression completely, let's go ahead and review some of our factoring rules again. Okay, so some of the formulas we need to remember are as follows. The first one is the difference of squares formula. So don't forget, if you have a squared minus b squared, you have two squares and a minus, so you have a difference of square situation. So if you have this situation, this factors into a plus b times a minus b. Alright, so the procedure is as follows. You take the square root of the first term and the last term, and then you find the sum and the difference of the square roots, and then you write them in this format: a plus b times a minus b. Okay, so you want to remember that you can only apply this formula to the difference of squares if you have a squared plus b squared. This is not equal to a plus b times a minus b. Okay, you only have difference of squares. There's no such thing as sum of squares formula, so please do not make this mistake. Okay, next formula that we want to look at are for perfect square trinomials. So formula number 2, if we have a squared plus 2ab plus b squared, this factors into a plus b quantity square. Okay, so the procedure to generate this factored form is you take the square root of the first and the last, you bring down the middle sign, and then you express the relationship between the square root of the first and the last as a quantity square, putting the sign in between it, the first sign. All right, and this formula also applies to this situation where you have a square um, a square minus 2ab plus b squared. So you take the square root of the first and the last, and then you put the middle sign, the first sign between them. So your factored form is a minus b quantity square. So these are the three formulas we're going to be using to solve this problem. All right? Okay, so let's take a look at this expression right here. What do you notice is common to all three terms? Let's go ahead and write it down here so we can work on it. I have t to the fourth minus 16 x squared minus 2 times t to the fourth minus 16 xy plus t to the fourth minus 16 y squared. Now what you notice is that t to the fourth minus 16 is common to all three terms. That's the greatest common factor. So what do you do with the greatest common factor when you're asked to factor an expression? You extract it, right? So we're going to factor out this quantity t to the fourth minus 16 from all three terms. If we factor it out, we're going to have t to the fourth minus 16. So when you factor it out from the entire expression, it's as though you're dividing. Okay, so when you divide this entire expression by t to the fourth minus 16 as a result of factorization, just imagine as though that they dropped off. Okay, so what will you be left with? You will be left with x squared minus 2xy plus y squared. So the question now is, are you done factoring? And the answer is no. If you inspect this quantity right here, this t to the fourth is a square. Why is that? It's a square because the power is even, okay? And 16 is also a square because we know 4 times 4 is 16. So here we have a difference of squares. So how do we factor difference of squares? Let's go ahead and consult our formulas again. Remember we talked about it here, that you root the first and the last and you find the sum and the difference of the square roots. Okay, so let's go ahead and do that. We root t to the fourth and 16 and you find the sum and the difference of the square roots. Now what is the square root of t to the fourth? The square root of t to the fourth is what you get when you divide the power by 2. By the root you're taking, we're taking the second root, so divide the power by 2. So we have t squared. The square root of 16 is 4, so let's do the sum first. Let's do the difference first. T squared minus 4 times t squared plus 4. That is the difference and the sum of the square roots of these two terms. Now take a look at this expression right here. What do you think this is? This is also a special case. This expression is a perfect square trinomial. Let me go ahead and label them here. So these two that we talked about earlier, these are perfect square trinomials, okay? We have the first and the last are squares, and if you double the square root of the first and the last, you get the middle term, and the signs are either different or positive in between the terms, all right? So let's see. That's the situation here. We have x squared, just like a squared, 2ab, 2xy plus y squared. So this is consistent with formula number 3. All right. So since we have a perfect square trinomial here, all we just have to do is use a factoring trick. We take the square root of the first and the last, and then you see how this middle sign is what determines the sign between the square roots of the first and the last term. We'll apply the same idea here, just drop down the sign, and then we'll have x minus y quantity squared. Okay? Another way you can factor this perfect square trinomial is by using the x game or the factoring by grouping method. That also works here, but if you have a perfect square trinomial, you can just apply this procedure as a very quick way to do it. The problem asks us to factor this expression completely. That's the goal, factor it completely. So the question now is, have we factored this expression completely? And the answer is no. Why not? The first term, the first quantity, is a difference of squares. So we can apply formula number 1 again in factoring the first quantity. Alright, so let's go ahead and do that. What we'll do is apply the same procedure that we applied to t to the fourth minus 16. We're going to take the square root of the first and the last term, and then find the sum and difference of the square roots. Okay, so you're going to have t, the square root of t squared is t. Remember, just divide the power by 2. So you have t to the first power minus 2 times t plus 2. This is the factored form of the first quantity, t squared minus 4, because it's a difference of squares. Now, can we factor this? T squared plus 4. This is a square, this is a square, this is a plus. The answer is no. Remember, we talked about it earlier here, that if you have a sum of squares, it is prime. It cannot be factored. So we are going to leave this quantity exactly as it is, t squared plus 4. And then this is just x minus y quantity squared. So this expression right here is the factored form of the original expression. Okay, so that's that. So thanks so much for taking the time to watch this presentation. Really appreciate it. Feel free to subscribe to our channel for updates to other cool math tutorials such as this. And please post a comment in the comment section to let us know what you think about this clip, if you have any questions or any suggestions to help us improve our tutorials. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.